Hello everyone, my name is Manish. Today I am going to give a presentation on renewable energy source fed multi-level inverter. This is the abstract of the project. This article implemented a hardware structure of a single-phase inverter with Arduino with hybrid energy sources. This inverter generates an AC square wave using PWM generated by an Arduino microcontroller, and this Arduino helps in generating triggering pulses for MOSFET switching, thereby AC voltage is developed. Taking this as a reference, this paper simulated a renewable energy source-fed multi-level inverter, which consists of the windmill and PV cell as renewable sources. As there is a lot of change in power generation in the current world, there is a need of using renewable energy sources for power generation. And the 9-level inverter is placed for power conversion. The 9-level inverter is used for maximizing the output power to a higher extent when compared to other inverters. The energy generated by the renewable energy source is stored in a battery, and the circuit is parallelly connected to the inverter for the AC power generation. This is the hybrid energy sources system with 9-level inverter. This system consists of hybrid energy sources in which it consists of PV cell and windmill, in which they are connected to a storage unit which is nothing but battery. And this battery is parallelly connected to the 9-level inverter for power conversion. And with the help of this inverter we can increase the output voltage to a higher level. Now I will explain about boost converter. The boost converter is useful for stepping up the received voltage to a higher level. The circuit of the boost converter is shown below figure. The input of the boost converter is given from the output of the rectifier, in which the DC output of the windmill is converted to AC using a rectifier. In the boost converter, there are two modes of operation which can be seen in the figure below. Here you can see the control scheme of the project. Now I will explain about it. The below figure displays the control scheme of the windmill. The output of the windmill is given to the torque reference 1 subsystem, and the output of the torque reference 1 is given to the subsystem 2, which is connected to the saturation for the desired output, and it is compared with references. These are the output voltage and current waveforms of the windmill. We can observe the output voltage obtained and current waveforms of a permanent motor synchronous generator, the wind turbine, which is 3-phase. From the voltage waveform we can observe 3 phases R, Y, and B. 3 red color lines indicating the R phase, while the green color indicating the Y phase and blue color indicating the B phase. Similarly, from the current waveform, we can observe 3 phases R, Y, and B. 3 red color lines indicate the R phase, while the green color indicating the Y phase and the blue color indicating the B phase. The magnitude of voltage waveforms is ranging from -500 to +500, whereas the magnitude of current waveforms are ranging from -50 to 50. These are the output voltages obtained from the boost converter. The below figure shows the output voltages of the photovoltaic cell, rectifier voltage, battery voltage, and inverter input 1 voltages. As all voltages are of DC, the waveforms are constant. The red line indicating the output voltage obtained from the photovoltaic cell, and its magnitude is ranging from 0 to 1000. The blue line indicates the output voltage obtained from the rectifier, and it is ranging from 0 to 1000. The green line indicating the output voltage obtained from the battery, and its magnitude is ranging from 0 to 1000. The pink line indicates the output voltage of inverter input 1, and its magnitude is ranging from 0 to 1000. These are the input and output voltages obtained from the inverter. We can observe the input and output voltage waveforms obtained from the inverter. Usually, this inverter consists of two inputs 1 and 2. Input 1 voltage is given as V1 and indicated with green color. Its magnitude is ranging from 0 to 500. The inverter input 2 is given as V2 and indicated with blue color. And its magnitude is ranging from 99 to 101. As the voltages V1 and V2 are of DC, the waveforms are constant. Finally, the last waveform displays the waveform of the output voltage obtained from the inverter VAC. The 9-level inverter output waveform is indicated with red color, and its magnitude is ranging from -2000 to 2000. This is the 9-level voltage waveform obtained from the inverter output. We can observe the output waveform obtained from the inverter VAC, which is 9-level inverter output indicated with red color, and the magnitude is ranging from -2000 to 2000. Now I will explain about the hardware implementation of the project. This article implemented a hardware structure of a single, one-phase inverter with Arduino by hybrid electric sources, which mainly consist of, 1 Arduino Uno, which is a microcontroller, 2 MOSFETs for the inverter, 1 12V rechargeable battery for an energy storage unit, a step-up transformer, a dynamo for windmill, 40x40 solar panel for photovoltaic power generation, and lamp load for the output. The above-mentioned components were used can be seen in the below figure. The Arduino Uno is the heart of this inverter, in which it helps in generating the PWM pulses. It helps in switching off MOSFETs. The above block diagram from figure, of a single-phase inverter using Arduino with hybrid electric sources, exposes the total construction of the project. In the circuit, two hybrid electric sources were built which are a windmill and a PV cell, and are connected parallelly to a 12 volts rechargeable battery which is the storage unit, thereby a single-phase half-bridge inverter is built, using two MOSFETs which is the main component used for power conversion. The triggering pulses for the MOSFETs will be given by the Arduino Uno which is the microcontroller used for controlling the output voltage at the desired level. And now the 12V battery is fed to the inverter input. Through this inverter the DC supply given to the inverter is converted to AC by the MOSFETs. And the output obtained of the inverter is fed to the input of the step-up transformer for increasing the voltage level. And thereby the output of the transformer is connected to a lamp load. This is the hardware kit of the single-phase inverter with hybrid sources. The above figure indicates the hardware implementation of the single-section inverter which is connected to a lamp load. Here we can see the single-phase inverter output which is displayed on CRO. The above circuit was successfully implemented and output was generated with 220 volts 50 Hz supply at the output side, which is our desired output level. The inverter generated a square wave which is nothing but AC voltage, and this generated output waveform is displayed on CRO, which can be seen on the above figure. Finally, conclusion. This paper implemented the simulation of the renewable energy sources fed multi-level inverter and the output of the proposed system was shown. Hardware structure was implemented with a single-phase inverter using Arduino, which generated a square pulse by PWM with the help of an Arduino microcontroller and the output of the hardware displayed on CRO is shown. That's all for the day. Thank you all for giving us this wonderful opportunity and spending your valuable time with us.